Hello everyone, today we're going to look at usaco-training cow pedigrees. Okay, so in this problem we're given two integers, n and k, and we're supposed to construct a binary tree that consists of n nodes and the height would be k. Okay, so basically the degree of each node has to be either 0 or 2, which means that it has either 0 or 2 children. Okay, and then the height of the tree has to be equal to k. So then the height of the tree is equal to the longest path, or the number of nodes on the longest path from the roof to the leaf. Okay, so we're supposed to try to find how many possible trees are there, modulo by 9,901. Okay, so in the sample input, we're given n equals 5 and k equals 3. So then here are the two possible trees. So the first example, it satisfies the conditions because it has 1, 2, 3, 4, and 5 nodes, and same goes over here. And both have a height of 3 because to make the height of 3, you can have this path because it consists of 3 nodes, and same goes over here as well. Okay. So notice that the n is in the range from 1, 3, actually, to 200, so. Okay, and k is in the range from 1 to 100. Okay, and notice that we can never construct a tree that has an even amount of nodes, because let's just say if we want to construct a tree that has 4 nodes, there's basically like impossible ways, because you know that we always have to start with the root, but then every time we add new children, we have to add at least 2. So there's always an odd amount of nodes in a tree for it to be satisfying. Okay, so now basically, let's just say we're going to try to construct a tree with 7 nodes. Basically, 7 can equal to basically 3 plus 3 plus 1. So then, basically, we have a small tree over here. Again, these consist of 3 nodes. And then, basically, if we merge these to make a bigger one, so basically, if we add a root node over here, and we can actually connect these, okay? So then, the 3 over here is here, and then the 3 over here is over here, and last but not least, we have our root node over here. So then, basically, if we can actually apply dynamic programming over here, given that we can construct any odd number of nodes. Okay, so let me just write the DP state. So basically, DP of ij is equal to the number of ways to construct a tree of I nodes with the depth, which is j, has to be less than or equal to j. Okay, so what I mean is that, or actually the depth is actually the height. Okay, so notice that, let's just say we're constructing DP of 7 of 3, okay? So, for example, in this case, what you see over here, you know that this has a depth of 2. So then, basically, because every time we add a new root node, we're basically extending the height by 1. So then, basically, what we can do is that we can loop through all basically all like heights with k minus 1. So then, for this example, you know that this depth is 2. This depth is also 2. So then we can use these to form the top one. Okay, so let's just say you know how to you know like the number of ways to make this. Now now, like what we add to dp of 7, 3 is actually, we add these two multiplied together because these two like subtrees are actually independent. So then if we multiply them together, we can actually take the total amount of combinations. Okay, so then the pseudocode would actually look something like this. Okay, so basically we loop through from all like i's from 1 to n, since we actually want to calculate the number of nodes from 1 to n. So basically we can do, so I would be from 1 to n. Okay, so now we're going to loop through j, which is the height. Okay, so j would also be from 1 to k. And basically our base case is that dp of 1, j, is always equal to 1, because there's always one way to make one root node, and it would satisfy the conditions because the depth of this is 1 and it would be less than or equal to j. Okay, so now basically that's if I equals to 1. So what if it's not equal to 1? We're going to consider the case like over here. We're going to try to have two subtrees and we're going to try to merge them. Okay, so basically we can loop through 4k, and it can basically be from 1 to n. Actually, it should be 1 to I. Okay, so it should actually be from 1 to I minus 1. Okay, so then this k, we're going to try to merge these two, and this should be size k, and this should be size I minus k minus 1. And this is because the minus 1 is because we are adding a root node, so this actually is like this actually should count in this. So basically if you add 1 plus k plus I minus k minus 1, then this would be I. Okay, so then for each of these we can just increment this by dp of k, as I said before. And then since we're actually using one less distance, then so you would do j minus 1 times dp of, as I said over here, I minus k minus 1. So I minus k minus 1 and j minus 1. Okay, so then now basically after we calculated this, we actually have our prefix sums of the values. So our answer would actually be dp of n, since we're making n nodes, of k, but this would actually include the prefix sums if the depth was from 1 to k. So then you just subtract this by dp of n, k minus 1 to get our answer. Okay, so let's actually start implementing this. So this is cow pedigrees. Okay, so let's include bits. Okay, so we're going to read two integers, n and k. We can actually make them global variables. Okay, so then we're going to construct the dp matrix. So then we can have int dp of the maximum n would be 201 and the maximum k would be 100. So let's just make this like that. Okay, so we're going to loop through from I equals 1 to n, and we would loop through j equals 1 to k. Okay, whoops. Okay, so first we need to consider if I equals to 1. If this is the case, then our dp of I, j would be equal to 1. Okay, otherwise, we will loop through each small k from 1 to I. Okay, so for this case, you know that this is our first element is k, and our second one is going to be I minus k minus 1. Okay. So then basically your dp of ij would be, you would add this to dp of k, j minus 1, times dp of I minus k minus 1, j minus 1. And then you would just mod it by what we're given the input. So we're actually going to mod by this number. Okay, so after this, basically let's call this our answer. So this should be equal to dp of nk minus dp of nk minus 1. And note that since we actually mod it over here, this could be negative, so we just add this number, and then after this we just mod it by this. Okay, so then we just print our answer. Okay, so this is cow okay, so let's run main. Let me get the input, so it actually should just be 5 and 3. Okay, so 5 and 3. Okay, so that's nice. We have 2 ways, which is correct. Okay, so let's actually, since we're going to read from no cows, that in, and we're writing to no cows, that out. Okay, so I'm just going to submit it. This is no cows and language is C++. Okay, so here's the problem statement. Okay, so this is cow. Okay, so looks like that is right. Okay, so if you have any questions, feel free to leave them in the comment section below. Bye.